So hi, I'm Brendan. Thanks for those of you who've stuck around to hear me. Thanks for listening to me. I normally talk a lot about technical stuff, but today I'm going to talk a little bit more about the social aspects of building technical stuff. It's something that I've done a bunch over the course of my career. I don't know how, I've lost count of the number of teams that I've built over the years, from open source projects to internal teams to small teams within larger teams. I've done a lot of this sort of going from 0 to, in some cases 5 or 6, in some cases 60, 70, 80. Kubernetes is now 900 plus contributors, so that's really kind of scaling in a different way. And so I wanted to talk in some ways about how you do that and how you organize your software in order to be able to do that. All right. So I also took another experiment, which is, this is also the first time I've had a laptop with a touch screen, and I decided I was going to handwrite my slides. So we'll see how that goes too. So why do I care about microservices? But more importantly, why do you care about microservices? Do you care about microservices? I would actually say that you don't care about microservices. Not at all, right? And there's been a lot, God, 20 years ago when I started in the software industry, we'd get these resumes, and we would call these resumes buzzword compliant resumes, right? And because they would be, they always list out their technologies, and it's like, at that time, this shows how old I was, it was like servlets, EJB, unit testing was kind of a thing then. It was just starting to be a thing. People would just sort of check these things off, and I think sometimes there's a degree to which that's the way we approach these things. Like, hey, it's everybody says that we should be interested in this thing, so we're interested in this thing. But I like to take it apart and actually talk about, why are we actually interested in these things? And I think we are actually interested, but for reasons that don't really have a lot to do with the technology. Because at the end of the day, the things that you care about are, you care about your product, right? You care about the thing that you're building. You want that thing to be useful. You want that thing to be helpful. You want that thing to be something that you imagine that you need to bring into the world. I think one of the greatest traits, and I think the talking about how you inspire this sort of thing, I have a daughter myself, she's 8. And so she actually does get to use the power tools. We negotiated, my wife and I negotiated what age she could start using the power tools. I got 6. I was pretty happy with that, actually. I thought that was pretty good. I started lower than I was actually comfortable with so that I could maybe end up with a place. That's negotiating for you. But I think that one of the things that I really want to instill in her, because this is something that really means a lot to me and that brought me into technology, was the notion of creating something, the drive to build something. That really powers you, and the notion that you can actually change the world. That moment, she was talking about plugging in the stereo, that moment when you realize you did this thing, this thing that didn't exist now exists, is something that drives a lot of us, and I think that's one of the things we care about a lot. We don't care about microservices. Hopefully you care about your users. This is also something that I think a lot of people kind of fail on. We care a lot about our technology, and we care a lot about our idea, but is our idea something that is useful? Well, you should care about your users too, and hopefully you do. And you care about your team. And hopefully you do, because we're social people, right? You probably spend as much time with your team, maybe more time with your team than you do with your family. And while that is sort of sad at some level, it's also really good. And you should care about these people. You should care about them at a personal level. You should want them to be successful, and it should feel like a team. It's called a team for a reason. And I would like to also say that this has happened before. And this happens over and over again. And I said with EJB, with SOA, service-oriented architectures, with, object-oriented programming before I came into the industry, ... It's the great quote about real people programming in assembly language. But this keeps happening over and over again, and I think that the reason this keeps happening is it turns out actually building software is hard. But I wrote this down, and I thought about it a little bit, and I thought, well, actually, I don't actually think building software is that hard. Not for me, and I think not for a lot of people. Once we get over that hurdle, writing code is actually not that hard. Teams building software, on the other hand, is really hard, right? And part of that is because, I've got all this context right here, and if I'm by myself hacking away, that's probably why I like hacking away by myself. I don't have to share it with anyone, right? But the minute you have a team, you have to share that context. You have to figure out where the interfaces are. You have to do all of this social stuff, right? You have to deal with the fact that you get to write the cool thing while the other person is fixing unit tests, right? or whatever else it happens to be. You have to deal with all this social stuff around the fact that these are multiple people, multiple thought processes. We can't mind meld. We can't be the Borg mind and write our software together. It'd probably be easier if we could. And so I think I come to the conclusion in many respects that the current interest and the current focus around things like microservices is actually about scaling teams. There's a lot of other reasons in terms of reliability and scaling your architecture for having microservices, and those are very true and very valid. But I think that the most interesting part of it has to do with the fact that in building these architectures, you're actually setting up teams for success. It turns out that the ideal team size is about 5 to 6 people. Does anybody disagree with this statement? I'm just curious. Because I think everybody's felt this, right? I don't know how many of you have gone from 1 or 2 people in the basement to 5 or 6 to 20 or 30. But there's that moment, like 1 to 2, it's kind of like, God, we really need more people because if only we could just move a little bit faster, like it'd be awesome. And then you hit that 6, 7, 8, 9, 10, and you suddenly start feeling the weight, right? Suddenly it stopped being like, great, we had all of this stuff and now we're all moving, to suddenly like, and I think it's about space, right? Like when you had 2 people, there was just so much space. And at 5 or 6, like you still have enough space that you can kind of still move autonomously and independently. And at 10, 15, 20, suddenly you both can't see the far end of the space, right? Like I'm at one end and this other guy is way at the other end and I can't actually see what they're doing. And then also we get a little bit more crunched together, and so there's naturally more friction as we move, right? And so I think that, and there's academic research as well to back this up. I think that there's a lot of reasons for why this is true, and so what we're trying to do with microservices, I think in many respects, is try and figure out how we can keep this to be true even as our software grows. So one of the values of being at 5 to 6 is you can all sit in one room. I'm a huge believer in open space and sitting together, right? Like as I said before, it's a team. We're all supposed to be sharing information. We're supposed to have one brain. Sitting together in one room really helps with that. You also can understand all the code. 5 to 6 people, it turns out the amount of code you can churn out with 5 or 6 people, pretty much everybody on the team can still hold that code in their head. Past 5, 6, 7, 8 people, you suddenly stop being able to hold all that code in your head, and this slows you down, right? When I dive into parts of large code bases, even large code bases that I have been intimately involved in writing the entire code base, when I have to dive into parts that I'm not in all the time, it takes me a long time to swap in, and that slows everything down. Also, you can understand the project at this scale, right? Like at 5 to 6 people, you can kind of understand where you're going and what you're supposed to be doing. Bigger than that, suddenly there's bits that you don't necessarily think about very much, right? You're really on the back end side and somebody else is doing the UI, and they may as well be in a different country, right? And finally, I think you're all on the same team, right? And I think this comes back to the social parts of it, which is that at 5 to 6 people, you're still pulling all in the same direction. You still believe that your success is your neighbor's success. You still, effectively believe that helping that person to understand something and move them forward is helping you. But once you start getting bigger than that, suddenly it's like, oh no, well, they own the CLI and I own the API, and so, well, if the CLI sucks, it doesn't help me that much if I help the CLI, because the CLI team will get that credit, right? That's terrible, right? Like if you're in that world, you're not moving your product forward and you don't believe that the team's success is your success. And so we have to stay in a world where we believe that the individual is a piece of a larger puzzle. But as it turns out, eventually most large projects need an army, right? There just is a lot of these problems that we do. I mean, I was thinking about this with the GE digital talk earlier, all the turbines out there building this data, you can't do that with 5 or 6 people. It just doesn't happen, right? Or maybe it does, but it takes centuries. And you've forgotten about what you did a century ago, and you're dead, so. New York Times said 115, by the way, yesterday. That's where we cap out. I don't know. We'll find out. Anyway, so the challenge here is how do you get to the place where you can have that army that you need for the project that you need to build and still be agile? Because it turns out armies are really not agile, right? They're not built for moving quickly at all. They're built in this hierarchical way where you can command them, and that's good, right? It's very, especially with moving armies, it's very important to be able to command them around, but they don't move fast, and it's very hard, and things get diluted, and telephone, and all that sort of thing. And the other problem, of course, is engineers aren't exactly good at following orders, Like, that's my experience in general. Like, we got into this thing because we liked building things. We liked to impact the world, and it's very personal, right? It's not like, oh, I like to listen to whatever that person says and do that, right? Also, honestly, I believe you build bad products that way, to be honest. Like, I think if you are an engineer and you're saying like, oh yeah, I built that feature because my lead told me to build that feature, I'm not really sure what it does for the user or anything, but he said to do it, so you're not going to build a good product that way. And so we need to embody this sort of thing. The good thing about this, though, is unlike armies, which kind of have to have lots of people and move in conjunction, most software is composable, right? So we can actually break this problem apart. We can actually move independently. We can build pieces. We can glue those pieces together. We can achieve the larger goals in a way that doesn't require the same kinds of things that, occupying a country requires. All right, so what do you need? Well, I think one of the most important things you need up front is to plan to grow, right? How many people here have started a project? All right. How many people here defined their APIs first? 2, 3 people. How many people defined their APIs first the first time? Right. So I think sometimes we learn from our mistakes, and that's great, obviously. But I think that one of the things you need to go into, and I think at this point, let me take a step back. How many people set up unit test infrastructure as part of the project when they're starting? Right? Definitely more hands, right? If I'd asked that question 15 years ago, I don't actually think that would be true, right? So we've evolved. We understand now that there are parts that you just kind of have to get in place that are part of this is the package that I use to start this thing, because I know that if I don't get my unit test infrastructure in place in the first cut, it'll get procrastinated, and my code will get cruftier and buggier. And when I put it back on, I'll take 6 days just getting all the tests to pass. We understand that, but I don't think that we understand, hey, you know what, if we're building these projects, we should build with the anticipation that suddenly there are going to be 15 or 20 engineers on this project. And how do I set myself up for that kind of success? And then additionally, I think we all sort of plan to scale our infrastructure. We're sort of like, you know what, when we're really famous, we're going to need to be able to scale to, and sometimes that's actually kind of ludicrous, but I don't think we plan to scale our teams. All right, and then I think the other part of this is in doing this thing, we're seeing this transformation, and it's for a lot of different reasons, but we're seeing this transformation where the honest truth is products are UX on top of APIs. That is literally, I think, the definition of of how you should build a product. It's a UX on top of a bunch of APIs. Maybe it's a mobile UX, maybe it's a web UX, all of the above, right? And that's why it's becoming this. But when you start thinking in that way, and you start thinking like the product that I'm going to build is a UX on top of a bunch of APIs, you've started naturally to decompose things into these modular components and these teams. Anyway, these microservices, if you will. All right, so how do we scale teams? Well, the very first thing is we draw boundaries. This is okay, this API, you're the UX team, go from there. We decouple, meaning we really make sure that the boundaries are crisp. This is the equivalent of making sure your abstractions don't bleed. Like, you make sure your boundaries are crisp, and you empower. And I think empowerment is actually maybe almost the most important, right? Each team needs to feel like they own their thing, right? They are empowered in their world. In order to do things. And the way you empower things is you say, teams, you know what, you own your APIs. And you own your APIs like they're your product. You may have no other consumers than the team next door to you, but to them, they are your customers, they are your users, and this is a product, which means things like deprecation, right? Think about what deprecation means and have an idea of what you think your deprecation policy is. Even if no external user will ever see the light of day, you need to understand what your deprecation policy is, because if you don't have a deprecation policy, then you have coupled teams, right? Because suddenly, in order for me to move, I have to talk to this other team and say like, hey, we're going to change this thing. You need to change your software too. And likewise, as a team, I can be like, I have this dependency, but I don't really trust you because you could break me at any time. Like, that's a bad world, right? That's not an empowered world. That's not a decoupled world. You have to have deprecation policies. You have to have documentation because, again, you're trying to treat this thing like it's a product. It's a decoupled product. People need to be able to consume it. They need to not come to your team and ask you how to use it. They need to look at the documentation. And finally, you have to own operations. As a team, you own the reliability of your service. Right? That is what you do. You are producing this API, even if it's never been consumed by an end user. And I think that this is the way we achieve. Like, all the other things are awesome, and I think teams love to have them. and all of these things, I think in many respects are things that teams don't necessarily want to do because they come at a cost, but you can't have one without the other. All right. And most importantly, teams interact via these APIs, and this is really the only way that they interact. Wouldn't it be great if I could just like make RESTful calls on people? But this is the only way that they interact, right? And what this means is don't ask, don't tell, right? Which is you should have a mindset that what happens behind the API interface stays behind the API interface, right? I need my consumers to be able to believe that the API is what's important. The SLA of the API is what's important. How the hell you implement, it could be like gerbils on exercise wheels, and I shouldn't care, right? As long as you can meet your SLA. And that is, I think, a really fundamental distinction. As engineers, we really want to understand. It's funny because, like, I don't think anybody cares how, internally some cloud API works. We just kind of trust that they work. But like on Teams, if it's the team next door, you're like, wait, how did you actually implement that thing? You shouldn't care. Because if you start caring, you're not achieving this decoupling that's necessary to maintain these small team sizes. You're starting to build that big team instead of the small team. All right. Teams also need to trust no one, right? This is really important also, right? You get QoS per user, right? If you're going to have 20 different customers, you should have 20 different users 20 different products that are accessing your API. Even if they're all internal teams, there should be 20 different users, 20 different rate limits, all of this sort of thing, right? Like you need to understand who's DOSing you. If you don't have this, you won't, right? You need identity, and that's part of the same thing, and you need to have the security model as well, right? You need to trust no one if you're providing this kind of API, even if it's only an internal API. Because again, if you don't do this, you've let that boundary slip, and now your small team is becoming a large team. All right. And then finally, you need to dog food your own APIs, right? Because if your API is your product, you need to be using your product as well. And one of the things we pushed really hard for, and it was a bit controversial inside of Kubernetes when we were building it, was the notion that everybody comes in through the front door, right? There are no like, oh, I'm just going to access storage over here because I talked to that guy and I know that he put his data into that database, and so I'm just going to, I'm going to pull up my MySQL connection and talk to that database directly, make changes, and not go through the API. There's a bunch of different reasons. You can't defend the deprecation policy. You can't deprecate parts of your database if suddenly random people are manipulating the data in your database. That's part of it. Probably you don't have the kind of trust no one security that you ought to have if some team is able to reach into your database. And finally, if you don't do it yourself, you don't understand how your product works. Right? This is the equivalent of consuming your product yourself. I've seen this taken to the extreme, and I don't necessarily know how I feel about it. I've seen this taken to the extreme where people actually don't let there be internal API calls. Every single API call actually goes through the literal front internet door, even service to service, right? And obviously it doesn't actually route that way because you're still in the same data center or whatever, but they've taken this approach of really saying like, no, actually, we don't even, and given where we're at with telecommunications security, it might not be a bad idea to say we don't actually even trust the internal network, right? We want every service to treat the world as if it's being placed on the public internet, and you really come in the front door with all of the right certs and all of the right trust models in place. And I think that might be a little bit on the extreme end, but on the other hand, in many situations, it makes sense. All right. But there's a caveat, right? And you always knew that there was a caveat. And that's that if you really take this to the extreme, this is what happens. And you have you no longer have cohesion, right? This is what there's all sorts of analogs through history that can point to this, sort of like pre-constitutional United States, pre-unification in the 1850s Germany. There's all sorts of examples of like too much decoupling is actually a really bad thing, right? You can't achieve large goals if there's too much decoupling. So you get a lot of freedom. I'm not saying everybody has to program in the same language, but probably it should be one or two. Probably you shouldn't just allow teams to choose whatever the heck they want to do. You shouldn't have one team using Jenkins and one team using, an online CI/CD system and another team using Spinnaker. Like, there's a reason. There are good reasons for having shared infrastructure, and of course we can have YAML, JSON. So, see how long this theme can go for. I was trying to see how many people I could insult, but I deleted a few slides, actually. You should see the ones I deleted. You have to establish core infrastructure, right? There has to be choices that are made that are universal. This is partially actually for social reasons, because it turns out sooner or later someone on one of these teams is going to get tired of being on your team, right? You're going to need to move to a different team. And if moving to a different team means relearning absolutely everything, then it's like an external hire. And that's very hard, and it slows down the team, and it makes mobility tricky. And people don't even necessarily want to move because they like their skill set, or they like their tools, they like feeling like they're empowered. They don't want to switch to a team, and that's bad, right? You need to have this sort of social mobility that allows you to move from team to team to team in order for people to refresh themselves, share knowledge, like gain experience, even just grow their careers, right? Like that person may no longer be the right person to fit into this team given the sort of seniority levels and structures and things like that. You have to have common infrastructure so that you all kind of speak the same language. It also allows for shared understanding, right? It means that I don't just learn in a little vacuum how to configure Jenkins really well, and that knowledge doesn't transfer to my broader team. We want to have knowledge transfer. We just don't want to have coupling. So in a lot of these places, when you have core infrastructure, it's because it's a universal thing that you can draw across the whole world without really tightly coupling things together, right? And I know that there's lots of debates about mono repo versus modular repos, and I can see arguments on either side, but I think one of the benefits of things like mono repo is this notion that, yeah, actually a lot of the stuff is common and is core, and we want a team to own, a decoupled team, to own that piece. We want somebody to own CI/CD. We want somebody to own source control, right? So what are the things you can do in this core infrastructure? Well, languages, obviously, as I mentioned. Packaging and deployment, I mean, that's sort of coming down to a universal format anyway. CI/CD, it's just, I don't think anybody likes, well, the Circle CI guys are here, maybe they like CI/CD. I don't know if anybody else likes CI/CD, but it's so important, right? So like, if you get one team or you got those people who really like it, set it up really well, everybody uses that. I don't think there's this person out there who wants to configure Jenkins, right? I've done it a lot, but like, I don't think anybody really wants to. And then things like monitoring and logging and alerts, and these are critically important because these are the places where you build that tribal knowledge of what it takes to run a production service, right? And there's a reason why we share knowledge and we build societies. There's a reason why we built up university systems and academic journals and all this form of knowledge sharing. It's because there are places where they're simply too hard to have everybody relearn, or too important to have everybody relearn it every single time, right? You have to find the places where it is actually extremely important to codify and build up a body of knowledge. Monitoring, logging, and alerting are one of those places. I think fortunately with the evolution of container orchestration, a lot of these things are becoming just sort of dial tone in the container orchestration layer. So by the virtue of deploying things into a Kubernetes cluster or into a Mesos cluster, you just get monitoring for free, right? And so you can codify the monitoring in that layer, and that's really important. And there's more as well. Things like RPC infrastructure. This is something I don't think everybody does yet, but everybody's in the process of going. I think people are moving towards this. At least everybody has sort of more or less coalesced on a couple of different transport formats, but I think we're going to coalesce even more onto things, the client libraries that have metrics associated with them. I don't know if you've seen some of the Linkerd stuff that this startup named Buoyant has done, but it's very much in this line, and this stuff has been present in a lot of the hyperscale internet companies for a long time. This is a piece of common infrastructure that really should be spread across all your teams because it just makes life easier. Storage as a service, again, somebody mentioned, I was talking to someone and they said, someone said, well, if you just take storage out, building reliable systems is super easy. And you're like, well, yeah, if you take the hard problem out, But I think that's true, right? Take storage, turn it into a separate team, a separate product, a separate API. Doesn't matter whether it's, you run Cassandra by yourself and you have a team that's dedicated to run Cassandra, or you say no, we're going to consume a true cloud storage as a service. That should still, for most developers, storage should be an API call because it is a hard thing to do right. And so get the people who can focus on that, make that their thing, defend an SLA for that thing, protect the API with all of the identity and security and trust no one that I talked about, and run it separately. That will make life as common infrastructure. That's a huge, huge value. And analytics as well, right? Understand what's going on, understand how your product's being used. A lot of times, yes, it's a whole bunch of different APIs, but your analytics need to be at the integrated level, right? Analytics are something where you actually want to understand, well, people who come and consume this API then consume this API, and this is how they go together, and latency over here affects latency over here. You need that kind of like high-level understanding of your system that the talk earlier was about to really make progress on your product at the end of the day. And so there, again, you need to have places where there's common infrastructure so that you can have that systems view. But you need to make sure that the places that you put it in are places where you are sufficiently decoupled. And again, analytics should treat themselves just like they're another one of these, decoupled, empowered teams that everyone consumes. All right, and that's it. That's pretty much all I have. I have no idea how I did on time. 25 minutes. But I really think that as we think about all of these software technologies, what we want to be thinking about is not it's the latest thing that I need to learn, or it's the thing that's going to help me build my more reliable software. It's how is it actually going to help me improve the process of building software and the social construction of the teams that we use to build software. Because I actually think that that's mostly what we're trying to do anyway with all these frameworks. We're trying to make it easier to build teams and build a software system that scales as the product scales. So, thank you. Oh, yeah, sorry, question.
So, kind of 2 points that are really related. When you treat each individual microservice in this case as a product team, and you treat it as a product with consumers, you lack the economic pressures of competition, and there are a lot of bodies buried. I know you work with there's some bodies buried there as well about certain teams that didn't do well, but because they owned that and there wasn't sufficient competition, that survived a little longer than it should have. And I think that's an artifact of kind of the difference between the perspective of this and from the first presentation about systems thinking, that there tends to be a really strong tendency towards line of work, line of business, line of product optimization that doesn't take the whole system to a view. So, if you have a little time,
yeah,
maybe some dead bodies.
Well, I mean, I guess what I would say is those dead bodies always exist in your software. Those dead bodies are always in your software. It just turns out that oftentimes they're linked into your software, right? And so, there aren't, within a large piece of software, there aren't economic pressures at some level, right? The product has to succeed, but whether it's a monolith or a bunch of decomposed microservices, how you built that thing and the team that built that thing and the service that's kind of useless that nobody uses or everybody has to use but they don't really like that exists whether you're decoupled with APIs or not. The only difference is if you decoupled with APIs, at least there's a chance that you could re-implement it, right? At least there's a chance that you could build something that's better behind it if it's not reliable enough or anything else like that. And in a tightly coupled system, I think it's a lot harder. So I think that's what I would...
Who does the systems level thinking in this utopia of 5 to 6 person teams that all treat their individual product as their product?
Yeah, I think that you do have to have someone or something. I guess what I would say is 2 things. One, my hope is that everybody is thinking about the overall product, right? You're not building an API. You should be thinking about your API as a product, but you should think about your API as how it contributes to the UX that's on top of that, right? You should understand. I guess as well you can say that it filters down at some level, right? So it's if the UX team needs a feature and this is one of the challenges, I guess, as well in these kinds of decoupled systems, is it's hard to push, right? I need a feature, so I need to push into this team, who needs to push it into this team, push into this team. 6 months later, you're yeah, I guess we got there, maybe. But then the requirements changed up top, right? And that's true. So I think that you have to have individual products understanding their role in the larger ecosystem. I think that's doable. Probably there's, architect is kind of a bad word, but probably there's a role for an architect-y kind of person, although my experience with those sorts of people is mixed. I think it's a challenge, but I think it's better than building the monolith 100-person team, I guess. So I don't know.
I agree.
It's hard, as I said, right? I'll come back to building software as teams is hard. So.
Somebody's controlling the investment in right? Each team has some proof, but there's some decision that someone has made about how many resources, what kind of resources to throw on to each one of those components. And someone has made a decision.
Yeah.
A group of people have made a decision about how it's broken down.
That's also, there is that economic pressure. I mean, there is that economic pressure of like, nobody uses that service, or they're not gonna get any headcount, and maybe they survive, but they don't grow, right? And then we grow over here,
So
so.
I think economic pressure does come through that, and it comes through what teams are, what's the investment, what component, and how did we break this down? Did we, break storage down into, 10 different specialized pieces? So we did, one team doing one thing.
Yeah.
All right. So we're good. We gotta move on to the next presentation.